Welcome to the next video of my Godot introduction series. In the last tutorial we have covered the basic scripting for our character. We can have some collisions now, we have a basic movement from left to right, and we have a gravity. Now in this video we will refine the movements and make it a little bit more snappy and add a camera which follows our character. Also we will implement a jump behavior, and I think that will be it for this tutorial. So let's start with it. First of all we will create a new function which is called move, and this move function will be used to move the character smoothly, so to accelerate him and to stop him. So therefore we will create a new variable which is called current speed, and this will be of a vector type. So let's type in 0, 0, and we will create a new function which is called move, and it will take a speed value, an acceleration value, and a delta value. Delta is used to make the everything frame rate independent, so it doesn't matter which frame rate we have, the delta will always multiply on our speed, and we have a constant speed then. Okay, so to create a smooth acceleration for our character, we will type in current speed dot x equals, and Godot has a function which is called, which you can find under the GD script. Here we have all sorts of mathematical functions, and we will use the lerp function. This is used for lerping a value smoothly. So we take again the current speed dot x, and now we type in which speed we want to have, and this will be speed as here defined. And now we type in the acceleration multiplied with delta, so it is frame rate independent. Next we will set the linear velocity. This is done via set linear velocity. Now we will copy this vector here and paste it in. Now we will use the current speed as the speed value here. So okay, now the function is done. That's already it. So what's the problem here? Here we say of course lerp. So this is the function we are calling, and now we can replace our set linear velocity here with our new move function. So we type in move. Now we use this player speed value here, player speed, this minus, and we create a new variable, export var acceleration. Let's type this to 5, or set this to 5, and this we will put in here, acceleration. So okay, let's change this here to, so you won't have the same name here. Okay, so now we copy this function, put it in here, and now we say plus speed, and also you put it in here and use 0. Now let's see what happens. You start the engine and we get an error. So what's the problem? Okay, it takes 3 arguments and we only have 2. Okay, so we have to put in delta here. So we put in delta, and now let's start the engine. So now you see that he's accelerating and decelerating, and we can change the values here. For example, let's try it with 8 and see if this is better. So now you can customize this as you like and just use it the way you want to. Okay, we will increase the speed a little bit by the value of 400, for example, and turn off the friction, because we are stopping our character with the code now. Okay, that's it for now, and now we will add in a camera, so the camera will follow the character and will have a smooth following. Therefore we select the rigid body and just go to the nodes here and type in camera. So we won't use the 3D camera, but instead we use the 2D camera. Create it, set it to current, and let's see what happens. So you see we have a camera that is following, but it is following instantly. So we will increase the smoothing value by 6. Set this to 7 and zoom a little bit out. And set an offset here, so -100. This is zoomed out too much. But you see, okay, we have now a moving character, we have a camera that is following, and what we miss now is some extra gravity, because the character looks or the gravity is not enough in my opinion, and that we will change now. I will set the margins here better, or okay. Now if you jump over to the rigid body node here, we see that it has a function which is called, where is it? Okay, I don't find it now. We just type in here set applied force, and this will give an extra force. And vector 2, and we will call this extra, or in the x direction we won't have any force, but in the y direction, and this is called extra gravity. And this is a value we want to export to. So extra gravity equals, let's say, 300. Okay, and here we have to close the bracket. Okay, this looks better. Let's increase it a little bit. 400. Okay, nice. So next will be the jump behavior. For the jump behavior we need to know when the character is on the ground. Actually we don't know this, and this is something we will change now. Therefore we will use Raycasts in Godot. So a Raycast is a ray that is going to one direction, and if it hits something you will know that. So what we will do now, we will cast the ray downwards, and if that ray hits the ground, it will say, hey, you are on the ground, you can jump. So therefore we select the player again and type in Raycast 2D. So you see there's the Raycast. We have to make sure that we enable it, and we'll increase the size a little bit. So let's say it's 60. Now if you want to access this node in our script and use the functions that are here, we cannot type in the function directly, because we are using, or we are extending the rigid body node here. But if you want to access this Raycast node, we can do it this way. We will create a variable which is called Raycast down, and at the moment here it is a null object, and we will assign it in the ready function. So to get the node, Godot provides a function which is called getNode. So we type in Raycast down equals getNode. And now we just have to type in this string name here. So we type in Raycast 2D. And we can test it. Let's print the name Raycast down.getName. And let's see what happens. So you see we get the Raycast. If the Raycast is, for example, in the second node, so it is in here, in this extra node, we have to type the path in here correctly. So we say node 2D slash Raycast 2D, and you see it works again. So this is pretty simple to get a node as a reference here, and we will reparent it again because you don't need the node here, and remove this one. Now let's create a variable which is called, or we will create a function that is checking for the ground, and we will call it func check ground, or let's call it is on ground, and there we will use the Raycast. So let's see what the Raycast has, what functions it has. It has a function that's called isColliding, getCollider, and these are the two we are going to use here now. So we type in if Raycast down.isColliding. Let's try it. Print I hit the ground. So now we are going to use this here and call the function, or let's say he's going to return this value. We print it for now. Okay. Now we call the function is on ground, and let's see what happens. Okay, you see, he says all the time, I hit the ground. Oh, oops, I hit the ground. That's because the Raycast is hitting its own collision shape. This one here, because it goes through that. We can add exceptions to Raycast, and that we will do now. So we have this function which is called add exception, and it will get a node. So we just type in Raycast down.add exception. That was it. Yep. And now we type in self. So the player won't be used as hit object. And now you see, okay, as far as he hits the ground, we see I hit the ground. Okay, and this is something we will use now. Let's do it. Return true. So if he hits the ground, he will return true, and otherwise he will return false. Okay. So nothing happens. And now we will add a new if loop and say if is on ground. Now this returns true or false, and if it's true, we will go into that scope here. So, and now we can create a new button input, which is called jump. So var btn jump, and this will be btn jump. Now go to the project settings and create a new action, which is called btn jump. Add it here, and let's add a key and use the spacebar. Close. Okay, now this is set up, and we have to assign it here too. So btn jump, btn jump. So if btn equal jump set linear velocity, or in this case we won't use set linear velocity, but instead we will use the function which is called set axis velocity. So we will just use one axis, because we don't want to set the x velocity, just the y velocity, and that's why we use set axis velocity. And now use the vector 2D. This is 0, 0, and this will be jump force. And this is a function, a variable that we will define here. Export var jump force equals, let's try 200 and see what happens. Okay, jump force, and here we have to close the bracket. Okay, now let's start the game and see what happens. So you see nothing happens. Let's increase the jump force by, let's add a 0. So do we get, let's check this is set to true. Okay, let's see if we get in this function here, print test. Okay, we get in the scope here. Now let's see if we get in here. Okay, we also get in there. And sorry, it has to be of course a minus jump force, because 0, 0 is here, and if you want to move up we have to use a negative y value, and this works. Okay. The only problem we have now is this test value is always triggered, or this btn jump, because he just looks if it's pressed or if it's not pressed, and we want to see if it was just pressed. And Godot has a function for it, I think, but I have written my own class for that, and I will copy that into the project folder. So let's add it here, and I will introduce this class in a moment. So let's add this here and see what it does. Input states. So we define the input states the same as here, but this function has or this class has a check function, and it will return a value from 0, 1, 2, or to 3. And these values will give me a hint what was done right now. So if it's 0, the button is released. If it's 1, the button is just pressed. If it's 2, the button is pressed. And if it's 3, the button was just released. So this is a class I've written, and we can import this class here. So we just say variable input states equals preload. This is a preload function, and now we have to type in the path to this class here. So it is in the resource folder and scripts, and then input states.gd. So if everything works, he will find it. If he doesn't find it, he will say that. So you see, can't preload resource. So he will say, Godot will tell you if he finds the resource. Okay, and what we have to do now is we can create the buttons with almost the same function. So we just say input states.new, and this is the same one, and this is the same one. So, and in this case we won't need this one here anymore. We will comment them out for now. And here we have to say btn check equals 2. So you see 2 is pressed, and if the button is pressed we want to move him. Same goes for this one, check equals true. And here we can say now check equals 1. So if it was just pressed, it will have the state 1, and then it will go over to the state 2. So in this case we will apply this force only once when we press the button, and that's what we want. So let's see if everything works. Okay, you see the test is only triggered once, and this is exactly what we want. Okay, and now let's clean up the code here a little bit, remove the stuff we don't need anymore. So we have a nice clean script here, and let's increase the jump force to 400 for example, and see if that works. Okay, this looks nice. So I think that's it for this video, and in the next video I will show you how to create a state machine. We will differ between a ground state and an air state, and give him a few different moving behaviors. So I want him to be more snappy with the controls on the ground, but if I'm once in the air I want him to float a little bit. So this is what we will do in the next video tutorial, and maybe we will cover a few more stuff. And I hope you liked that video, and if you liked it, please subscribe to my channel and share this video with other people. Thanks for watching.